All right, 10.5, last section on integrals in chapter 10. We are doing fantastic. So here we go. We are going to find the area between two curves. Up to this point, you've been given the sketches. So now what we're going to do is we're going to need to make the sketches so you can see a beautiful connection to what you did in Algebra 2. So y equals 4 minus x squared. That's a parabola that opens down, and y equals x plus 2 is a line. So the first thing I'm going to do is I am going to find where the parabola and the line will intersect. Okay, that's going to be important. So find points of intersection. Then 2, we're going to make a sketch, okay? So in order to find the points of intersection, you just set them equal to each other. So then I'm getting everything on one side of the equation equal to 0. Then I'm going to factor it. So that's x plus 2, x minus 1. So the points of intersection are at -2 and +1. So, And if we have to extend the graph, we extend the graph. So I'm going to do this one, y equals x plus 2 in red. So I know that is a line. The slope is 1. Okay, so that's that graph. Then I have a parabola, and I'm going to do this one in green. If I set it equal to 0, I can find the x-intercepts would be at plus or minus 2. And then how about if I plug in x is 0? And then at x is 1, that was a point of intersection. So this one opens down. And so what I'm actually looking for then is the area bounded between. So it's right between here. So then the third step is you always take the top graph minus the bottom graph in an integral, okay? So the top graph is the parabola minus the bottom graph. And then the limits of integration are the points of intersection. That was -2 to +1. This should end up being a positive answer because it's all that yellow shaded region is all above the x-axis. So I should be thinking here. Okay, I'm going to pause, and what I want you to do is I want you to find, and don't do this on the calculator, okay? Don't do it on the calculator. Work it out, and then tell me what you get. All right, so this is -1/3 x cubed minus 1/2 x squared plus 2x. This is from -2 to 1. Okay, all right, so large, so that's -1/3 minus 1/2 plus 2. So that's 8/3 minus 2 minus 4. Okay, so now watch this. I'll kind of, do you see negative 1/3 minus 8/3 is negative 9/3? That's actually negative 3. Then I have my negative 1/2. Trying to avoid any fractions if I can. Minus negative 6. Okay, negative 2 minus 4 is negative 6, but minus a minus is a plus 6, plus the 2 is a plus 8. That's 9/2. So hopefully you got 9/2. All right, so in number 1, we did all of that without the use of a calculator. So that problem would be really good on a no calculator section. This next one, there's no way around it. You have to use a calculator on this. So in order to get the point, and I'm going to say POI is point of intersection, there's no way to do that unless you put it on the calculator. Like there's no way to algebraically solve that, okay? So I put it on the graphing calculator, and I want you to give me your 2 points of intersection. I got negative 2.998 and 0.6469. Okay, so I'm going to do this one by hand, just because I prefer using my brain. Here's the line. And then e to the 2x and then a plus 1. That plus 1 is down below. So again, you're going to have to use a calculator. If I plug in 0, e to the 0 is 1, so it's here. And then they're intersecting at 0.64 and almost negative 3. And that's an e to the x, it's exponential. So then I'm looking for this shaded region here. So the top is the line. Okay, the top is the line. So my area is going to go from negative 2.998 to this 0.6469. The top function is x plus 4 minus the bottom function. Again, there's no way to do that by hand, so you have to do this on the calculator. Just be careful on how you enter that. So tell me what you get. I got 4.83. All right, that finishes it up.